Another way to solve a system of equations is in using elimination. As I did in the last video, I'm not going to go through these steps with you step by step, but I'll explain them as we go through the examples in the next slides. When I use elimination, I'm typically looking for a situation like I have here, where I have my x's lined up with x's, my y's lined up, my equal signs lined up, and my constants lined up. So if they're both in the same form, that's what I'm looking for. In addition, I really want one of my variables to have the same coefficient or the same number, opposite sign. So in looking at this first example, I have a positive 1y in one equation and a negative 1y in the other equation, and so I don't have to do other steps to make them the same number, opposite sign. Instead, I can add these two equations together in a giant addition problem. 2x plus 1x is 3x, and plus 1y and minus 1y eliminates, and so in elimination, one of our variables will be eliminated. 8 plus 1 is 9, and now this is a very simple one-step equation where I can solve to find the value of x. Just as we did with substitution, I'm then going to take that value and plug it into either equation to find the resulting value of y. So I can use either equation. I'm going to use x minus y equals 1 and replace x with 3. And when I solve, I get negative y equals negative 2, which means y equals 2. My solution is 3, 2, the x value, the y value. I also could have plugged the 3 back into the first equation and still had an answer of 2. So our last example was very easy because I already had the same number and the opposite sign and everything was lined up. Here we can see that everything is also lined up, but I don't have the same number, opposite sign. If I added these together as is, I would get 2x plus 3y equals 1, and that didn't help me at all because I still have two variables, which means I cannot solve. So instead, now we're going to use that next step that says if not, we have to multiply one or both equations by a number to make one variable have the same number, opposite sign. I'm going to take my first equation multiplied by negative 1. And if I take everything in my first equation times negative 1, that gives me negative x and negative y and negative 1. And so now I'm going to use these two equations and I'm going to add them together in a giant addition problem. X plus negative x eliminates. 2y minus 1y is 1y, and 0 plus negative 1 is negative 1, and so I've found one of my two values of my coordinate. Now I'm going to take my negative 1 and I will plug it into whichever equation I choose for y. This gives me x minus 2 equals 0. By adding 2 to each side, I get that x is 2, and so my solution is 2, negative 1. This next example is a little bit harder still because even though everything is lined up, I don't have the same number even with the same sign like I did in the last one. So now I'm going to have to be a little bit more creative. I can look at the 2x and the negative 5x and see that they have opposite signs, but in order for me to make those numbers the same, I would have to multiply the first equation times 5 to result in 10x, and the second equation all times 2 to result in negative 10x. That's one option. I'm going to choose instead to take my whole first equation times negative 3 because here I have a positive 3y, and if I take this equation times negative 3, I will end up with negative 3y. So by distributing the negative 3, I get negative 6x minus 3y equals negative 39, and now I'm not using that equation anymore. I'm going to now add these equations together. Negative 5x and negative 6x is negative 11x. The y's eliminate. 6 plus negative 39 is negative 33. And I solve for x to find that x is 3. Take that 3, plug into whichever equation you want, and then solve the resulting equation for y. So I will add 15 to each side. 3y equals 21, which gives me y equals 7. So my answer is 3, 7. In this equation, again, I have everything lined up, but I don't have the same number opposite sign. I'm going to choose to eliminate the x's. So I'm going to take my whole first equation times negative 2, which will give me a negative 8x on top and an 8x on the bottom. When I distribute, I get negative 8x minus 6y equals negative 16. And now I'm not using that equation anymore. I'm going to add all of this together. 8x plus negative 8x eliminates like I wanted it to. But notice what happens here. 6y and negative 6y also eliminates, which leaves me with nothing on the left side. On the right side, I get negative 10. 0 does not equal negative 10 ever, so this is a no solution equation. No solution. If I graphed it, remember that would be 2 parallel lines. This system of equations is not set up well for elimination because they are not in the same form. So I'm going to go ahead and rearrange this equation to put them in the same form first. So I have 4x minus 2y equals negative 8, and I have negative 2x plus y, because I've now moved the 2x to the left, equals 4. I still don't have two numbers that are the same number opposite sign. So now I'm going to take this equation times 2, and that will give me, this one is still 4x minus 2y equals negative 8. I didn't change that one. This one I get negative 4x plus 2y equals 8. And now when I add these together, this is my other special case, this eliminates, giving me 0, and also this eliminates, giving me 0. 0 equals 0 is true, and because it's true, this is infinitely many solutions. Infinitely many solutions. Here's the last one for you to try on your own, then press play to see how you did. I'm looking for the same coefficient opposite sign, and I see that my y values have the same coefficient, but the same sign. So I'm going to choose to take everything in my first equation times negative 1 to give me negative 1x minus 2y equals positive 3. And then I'm going to add those values together. 4x and negative 1x is 3x equals 9. So x must be 3. And then I will replace x with 3 in either equation. I'm choosing that second original equation. And to solve, to isolate the y, I end up with 2y equals negative 6, which means y equals negative 3. So my solution is x value, comma y value of 3, comma negative 3.